So in this problem, we have four forces acting on a single point, and we're actually told what the resultant is at the start of the problem. So the first thing we want to do is make our diagram, and because we're in 3 dimensions, we want to be using coordinates for A, B, C, D, and E. So we'll start with the given coordinate system, which has Z up, Y and X, and then we'll just put on the different points that they gave us. So we'll have point A, point B, point C, and point D. Yeah, it doesn't have to be the scale because we're going to be putting the coordinates in here, but we do want a picture here so that we know what direction things are pointing. And then lastly, where all the points are emanating from point E. Alright, so from point E to all the other points, we have a rope connecting them, so we know the forces are going to be pointing from E to A, to B, to C, and to D. Okay, so I'll name those 4 forces FEA, FEB, FEC, and FED. So now I will put the coordinates of all these points up here. So I'm measuring them all from this common origin here, and I'm putting their X, Y, and Z coordinates. So starting with A is located at 3 in the X, negative 2 in the Y, 0 in the K, because it's in the XY plane. B is going to be 3 in the X, 2 in the Y, 0 in the K. C is going to be negative 3 in the X, 2 in the Y, and 0 in the K. And point D is going to be negative 3 in the X, negative 2 in the Y, and 0 in the K direction. And then E lies on the Z axis, so it's at 0, 0, 6. Alright, so we have the coordinates of all of our points here, so now we can start seeing what they gave us. So we're told, it's given to us that the resultant vector is negative 360k pounds. And just as before, we know that the resultant is going to be the sum of all of our, in this case, force vectors. So the resultant is going to be equal to FEA vector plus FEB plus FEC plus FED. And we also need to realize, as we saw before in 3 dimensions, that a vector can be expressed as its magnitude times its direction. So, for example, FEA, we can write as the magnitude of FEA times the direction U hat EA. The additional piece of information they give us is that because of symmetry, the tension in the 4 cables is the same, which means that the magnitudes of these 4 are the same. So this is going to be the same as what I'm going to just call F, U hat EA. So the only thing that's different between the 4 vectors are their direction, but their magnitudes are the same. So we can actually write the resultant as, breaking these down, it's going to be F U hat EA plus F U hat EB plus F U hat EC plus F U hat ED. So again, same magnitude, different directions for each of the 4 vectors. So what we have to do, ultimately, what we're asked to find is what the magnitude or the tension in each of the ropes is, F. So we already know R, we're looking for F. We have to find these 4 unit vectors. So how we find the unit vectors? Just like we did in previous ones. So for example, I'm going to start by finding U hat EA. So to do that, we can take position vector EA and divide by its magnitude. So position vector EA we can find by taking its endpoint minus its start point. So A minus E So that's going to be 3 minus 0 is 3i. Negative 2 minus 0 is negative 2j. And 0 minus 6 is minus 6k. Now we can find the magnitude of REA is just going to be the square root of the sum of the squares of these terms. So the square root of 9 plus 4 plus 36 is going to be 49. The square root of 49 is going to be 7. So it works out to be a nice round number here. So therefore we can find the unit vector is going to be each of these terms. So it's going to be 3/7 I minus 2/7 j minus 6/7 k. So that's the unit vector for EA, and we're going to do the same process for the 3 other unit vectors that we have here. So I won't go through all the steps for each of them, but I will write them down. So for EB, again, we're going to take point B minus point E, then divide it by its magnitude. So this is going to be 3/7 I plus 2/7 j minus 6/7 k. Same thing for EC. C minus E divided by the same magnitude is going to be 7. So this is going to be negative 3/7 I plus 2/7 j minus 6/7 k. And finally, U hat ED, we're going to have negative 3/7 I minus 2/7 j minus 6/7 k. That same process for these 3 as it was for EA. So now I have my 4 unit vectors. Now I can combine everything that I had before. Right, so as I showed before, R was going to be, now I can actually factor out that F. F times U hat AE plus U hat EB plus U hat EC plus U hat ED. So I'm able to factor out that F because each of these had an F on it, and this is going to make it a little bit easier to solve. So now I can just put in all the values that I have here, and I'm told what R was is going to be negative 360k is equal to F times, so U hat, this is negative 3/7 I minus 2/7 j minus 6/7 k. U hat EB is going to be 3/7 I plus 2/7 j minus 6/7 k. Plus U hat EC is going to be minus 3/7 I plus 2/7 j minus 6/7 k. Plus U hat ED is going to be negative 3/7 I minus 2/7 j minus 6/7 k. Now, just as before, I can combine my like terms, and we're going to see a lot cancels out. I have a negative 3/7 I, I have a positive 3/7 I. I have a negative 2/7 j, I have a positive 2/7 j. I have a negative 3/7 I. And looking back, this was a positive. Cancels this negative, this positive cancels this negative. 2/7 j, negative 2/7 j, 2/7 j, negative 2/7 j. And now I'm left with negative 4 negative 6/7 k. So this is going to simplify down to F times negative 24/7 k equals negative 360k. Now I can equate my left-hand side with my right-hand side. There's no i's or j's on the left, there's no i's or j's on the right, so if I take just those things in front of the k term, I'm going to get negative 360 is equal to F times negative 24/7. So the last step is solving for F. That's the tension in the ropes. And if I do that, I get F is 105 pounds. Again, the tension in the ropes are all the same, so the tension in all the ropes, 105 pounds.